All right, it's live.
All right.
Hey.
Welcome all to episode 53 of Indexer Office Hours. Today is March 22nd, 2022. And if anyone is new to Indexer Office Hours, we absolutely love participation. You can do so by voice or text. So either request to join the stage to speak or add your questions and comments to the stage chat channel. As a reminder, this session is recorded and will be distributed via public channels such as YouTube. So we do have an exciting agenda today, which has been posted on Discord in the stage chat. And we will be using 𝗨𝗂𝗪 as a token of appreciation for those that join us here live. We'll be distributing a 𝗨𝗪. To claim, you'll need to use the 𝗨𝗪 mobile app and a secret claim word. Listen out for the secret word later in the session. Claims usually close within 10 minutes after the end of IOH. Okay, so let's start with opening remarks. So there has been a new episode of 𝗨𝗪𝗂𝗟𝗶, episode 56, with Jeff Morris, who is a founding partner at Chapter 1. I have found this particular episode a goldmine of information. Here, Jeff Morris talks about being a VP of product at Tinder and how the challenges that come with growing a unicorn. He also talks about Chapter 1 being an early investor of the graph, how he thinks of the state of the web. So he sees Web 1 as a read-only space, Web 2 as a read-write space, and Web 3 as a read-write-own space, in which we have incentives and community and membership models. And he also talks about how the investment space has changed, where if before companies in Web3 were raising money just to survive, now that we are at a place where even in a low traction market, you can still keep on going as a company because there's more financial options available in terms of investing. These are just some of the things that I picked up. The episode is amazing. Do go and listen to it. And I'm just going to give a shout out to the 𝗨𝗪𝗂𝗧 hosts for the super snazzy sound effects from this week. Another exciting announcement, Graph Day for this year has been announced. This will be on June 2nd, 2022 in San Francisco. Please come and join us. This will be the second ever Graph Day, and apply to also hack at Graph Hack, which will be happening in the same week between June 3rd and June 5th, 2022. And the details are on the agenda for today. All right. Moving on to RepoWatch. In terms of major blockchain clients, this week for Geth, we haven't had any new releases. The last release has been version 1.10.16. In terms of Aragon, we do have a new release, version 2022-0301 beta, and I'm just gonna hand over to Kai to tell us about the problems he encountered with Aragon, please.
Thanks, Anna. Yeah, so we did encounter a couple of issues with Aragon, specifically with the underlying library that it relies on, libmdbx. There's a system call that it makes that affects kernel version 4.19 and below, which causes some indeterminism with accessing database pages. This can lead to corruption within the Aragon database. Luckily, this was caught by the upstream author of libmdbx. This is 𝗨𝘀𝗪𝗧𝗨𝘀𝗪𝗧. So shout out to him for catching this early on. We are awaiting a deployment, or we're awaiting an update from either him or the 𝗨𝗀𝗀𝗳𝗂 team addressing this. So anyone who's running Rocky Linux or any LTS Linux version that runs kernel 4.19 and below will be affected by this bug. But other than that, we've been running it on our Fedora test node. Runs great.
Is there an issue active for this?
Yes, there is an issue for it. Give me just a moment. I'll grab that issue number for you.
Awesome. Thank you very much. Yeah, please paste it onto the stage chat. In terms of Open Ethereum, we haven't had any new releases. Last release has been version 3.3.4. For streaming fast yet, again, no new releases. Last release has been Polygon version 0.2.14, which was a hotfix. Moving on to GraphStack. For GraphNode, no new releases. Last release has been version 0.25.2. And in terms of pull requests, we're a bit light this week on overall contributions, but a pull request 3354 from last week has been merged. This is about avoid checking chain continuity with subgraph pointer, block pointer if subgraph never processed any block. For indexer, service, and agent, no new releases. Last release has been version 0.19.0 pre-release. And we do have a new pull request number 393. And it changes new deployments so that the indexer assigns new deployments to index nodes with the least amount of deployments assigned. If that's confusing, it's basically balancing workloads in terms of where new deployments are assigned over multiple nodes. So thank you for submitting, Hope. And before we move on to Protocol Watch, does anyone have anything they would like to discuss regarding the GraphStack or the blockchain clients, or just any issues that you've come across this week?
Just wanted to note, I posted a link to the message I originally posted in the Indexer software chat for anyone to take a look at.
Thank you very much, Kai. Okay, and with that, let's jump on to Protocol Watch.
Cool. Thanks, Anna. Unfortunately, Juan couldn't make it today, so I'll be covering Protocol Watch. First up is the contracts repo, and we've had no major updates since the last Indexer office hours. The same is true for core network subgraphs. Forum governance-wise, there is GIP 25, the data edge GIP, and we're very excited to have Zach on the call to talk more about that later in the session. And otherwise, there's been the announcement of the arbitration analysis. How do you say that?
Analysis.
Thanks,
sorry.
guys. Oliver, I see you're on the call. Would you be open to saying a few words about that important initiative?
Yeah, so super excited that we have created this role. I have described it in the forum as well. So we all know that the arbitration cases, some of the disputes, they have lingered on for quite some time. And the goal here is to just create capacity and support the arbitration council that exists of, Ariel, Yanis, and Ford. Is Ford online? No, he's not. So that's the arbitration council. They continue to make the decision for the disputes, but they now have analysts helping to provide research data that is necessary to come to fair and equitable decisions on arbitration cases. And it's a lot of work. So we're happy that we have now Jeff as part of the team. He will also be very transparent in the way he provides the work, so it will all be posted in the forum in terms of what he delivers to the arbitration council, and then it really provides some relief for the council itself to hopefully get some faster turnaround times on dispute decisions.
Thank you, Oliver.
Welcome, Jeff. I don't think he's on the line, but welcome, Jeff.
Indeed, welcome, Jeff. It's worth saying that arbitration analysts don't actually make any dispute decisions. That responsibility still lies with the arbitration council, but obviously this work is critical to facilitating that decision-making process. Okay, finally for Protocol Watch, we have GIP 26, which is on principal protected bonding curves. A small update there where Brandon has just made some changes to the GIP to reflect that we might not want principal protection in the event of GNS upgrades. So yeah, just a small update on that GIP. And I think that is it for Protocol Watch this week. Next up, we have renamed the ongoing points of interest segment to something a little bit more succinct, and that is the pin board. So let's have a look at what's on the pin board today. As before, there's an open call if you are an indexer to submit your Postgres database locale. A link to do that is in the stage chat. Data that you guys submit is going to help us with graph node determinism. So if you run an indexer, please do submit it. It's a very quick process. Next is our usual highlight of issue 3059 on graph node, tracking variants of deterministic errors that are incorrectly categorized as non-deterministic. Once again, if you see instances of this, please do report them on the issue. Finally, or at least next, on the proposal to require a valid POI on allocation open, I think generally speaking, there is agreement that we should move forward on this. An official GIP is pending. There will also be a set of indexer agent changes that are pending, but there is a proposed implementation done by Ariel, which is pull request 554 on the contracts repo. And then finally for the pin board, touching on Sam's thread, proposing incentives for force closing stale allocations. I think it's worth touching on contracts pull request 549, which deals with some of the apprehension that has been communicated in that thread on the forum, that GIP thread. Pull request 549 provides a mechanism for indexers to effectively create altruistic allocations. And they can do so by allocating 0 tokens to a subgraph. So this, is great because it kind of clearly delineates altruistic allocation behavior from more typical market engagement allocations. And another small detail of that implementation is that it does allow anyone to close stale allocations after the max allocation period. And I guess one other thing is worth saying is that altruistic allocations, that is allocations made with an amount of 0, can only be closed by the indexer, and they are not subject to closure by anyone. Any questions on that before we move forward? Okay, cool. Yeah, Coulson, totally agree. I think this is going to be a fantastic upgrade for quality of service on the network. All right, so with 45 minutes to spare, we are moving on to the fireside chat that we have scheduled today. And I am so excited to say we're lucky to be joined by Zach Burns from Edge and Node. And today Zach is going to be sharing his insights on Data Edge and some of the other research work that he has been doing. Welcome, Zach. It's a real pleasure to have you with us.
Zach sometimes has mic issues.
That's all right. We can wait a minute. It's very unusual that we have this much time dedicated to a discussion today, so we got some time.
Oh, while we're waiting on the microphone issues to be resolved, there was one question I had with regards to the protocol. There was a proposal from 𝗨𝗂 𝗟𝗀𝗀𝗀 with regards to the indexer cut mechanism. It was over a year ago that this conversation started. Does anyone know where this is at right now?
That's a great question, Kai. I'm also waiting for that to land. I'm not sure of the status, though. Does anyone know?
Yeah, Ariel was just here. He's no longer. I don't see him. I can ping him. Maybe he can come back and give us an update on it.
Yeah, I'd like that.
Yeah, definitely. I'm going to add this to the pin board because it's definitely a relevant issue that we should watch.
Do you hear me now?
Loud and clear.
Yay. Sorry.
Yay. No worries, Zach. Thanks for joining us.
Yeah, thank you very much, Chris.
So to kick us off, I mean, you know, I'm sure many people know you from your work on the forums and on the protocol. You know, it's fair to say that you are spearheading many of the most challenging research problems in the protocol, often crossing quite a diverse set of you know, deep technical domains. So I'd love if you could tell us how your prior experiences have led you to focusing on these challenges.
Yes, you're too kind, Chris. I took an unconventional path that I would not necessarily recommend to everyone. So although I've been programming with computers since I was about 12, I made an unwise decision to get a degree in computer animation instead of computer science. So I thought what I would be doing is making software for computer animation, but ended up just learning a bunch of art instead. So it was an incredibly stupid thing to do in retrospect, but you know, somehow my teachers let me pass through all the classes by programming tools for my peers instead of doing the conventional assignments. The implication of that is that I spent maybe the first 5 years of my career reinventing the wheel in a primitive programming language called 𝗨. And I mean this in like the worst way possible, right? I reinvented everything from the simple algorithms like merge sort to, you know, constructs like switch case statements and profiling and generics, checks for overlapping geometry, you know, etc., right up to complicated systems. And this experience, although slow and unproductive, built up a muscle for solving novel problems. Even though none of those problems were in fact novel, they were all novel to me because I was not handed the cheat sheet that is a computer science degree, if that makes any sense.
Yeah, definitely. I find like I can see somehow that, you know, working your way through some of these like foundational computer science algorithms and problems. I've never heard of 𝗨, but you know, it sounds horrible. But you know, working your way through implementing these things and like thinking about how, you know, the data moves through the program and you know, like basic control flow constructs. I can definitely somehow see how, you know, the thinking and rigor that went into that connects to the data processing work that, you know, we're all working on at the Graph.
Yep. I mean, it really was a very low-level beginning.
Cool. So I guess like jumping into what brought us to this conversation, which was the Data Edge GIP that you posted in the forums. For anyone that's uninitiated, how would you describe the Data Edge concept?
So Data Edge is an Ethereum contract with nothing but an empty fallback method. There's no contract logic, no events, or really anything whatsoever that would cost gas, except for the cost of calling an empty method with some data payload. The magic happens when you then use a subgraph to index all of the calls to that contract. So you can write a subgraph with a human-readable ABI to decode and interpret the payload data from those method calls. So this moves all of the execution and all of the protocol logic off of the L1 and into the subgraph.
Right. Right. So it's really like the L1 is purely used for efficient data storage, almost like a message inbox for the subgraph. Is that fair to say?
It is fair to say, right? It turns the L1 kind of into a data availability layer, although you still can interact with this with the data edge through smart contracts, right? So there's sort of a mix between pure data availability, if you're just say calling the contract directly in a transaction, or you can still have maybe like ownership of an NFT move through the system and give that permissions to call the contract or something. So it's kind of like a hybrid of data availability and smart contract execution in its own space in the system. That's the best way to describe it, I guess. I mean, it's starting to kind of think of the graph as like a read-oriented roll-up chain.
Super interesting. Yeah. I kind of see that theme of the separation of data availability and storage and computation. And can't help but kind of see the overlap there with, the body of research that has gone into scaling Ethereum and layer 2 solutions. So can you tell us about some of the observations and thinking processes that led you to propose this pattern for the graph and subgraphs?
Yeah, I think a lot about scaling blockchain technology, because for the things that we want to do in the future, right, to really operate at a global scale, we're going to need something a lot more powerful than what we have. What we have is useful for sure, but there are many more applications to be considered, and we need to scale a lot more to become very relevant and economically viable to society at large. And so in that context, I think about what can the graph do to help layer 1 and layer 2 to scale by removing the responsibility for indexing and query from them, so that they can focus only on the pieces that they need to focus on, right? Simplifying their designs and thereby enabling them to make optimizations. There's kind of a trend in the blockchain space about breaking up the individual responsibilities, right, of different layers in the blockchain stack, and not trying to do everything with one piece. Let you mix and match these pieces and simplify the individual pieces, thereby allowing you to do unique kinds of like sharding and things like that. This is something that I would like to give a more comprehensive talk on in the future, about where the graph fits into the stack and how it can affect the design of the overall blockchain space. So maybe that will happen on Graph Day. So stay tuned.
Sounds like an alpha leak to me. That's super interesting, Zach. And I definitely agree that this fits well into the modular blockchain thesis. But yeah, I'd definitely looking forward to that talk, because it would be good to understand, exactly how the graph fits into that broader stack and how it compares to some of the other scaling solutions that I guess are, at least in their present form, more oriented around so-called on-chain computation or on-layer computation. But yeah,
I'm looking forward to it as well. I also hope to understand where the graph fits in. And maybe by the process of writing the talk, I will come to understand that. That's kind of like half of the goal, right?
yeah. We've spoken before about how the writing process can really help to, structure and I guess battle test the argument. Cool. So as per the proposal on the forums, data edge, or at least data that's passed into the data edge contract, should reduce the L1 storage gas costs to their theoretical lower limit, which is awesome. So how do we achieve that? How do we actually minimize the storage costs for data posted to the contract?
Right. It's not just the storage costs, but the overall gas cost to the theoretical lower limit, because we've eliminated all execution. So that goes to 0. And then all that's left is storage, which you can then squeeze down to its theoretical lower limit. So then you get the overall theoretical lower limit. And compression is really the key here, right? One of the nice things about decoding the data in a subgraph is that you can implement custom compression, which has the potential to bring the size of the data down to the level of entropy required to represent changes, if you're willing to put in the effort. All compression works by making predictions about the data. If the prediction is good, you can represent the value with a few bits, but if you're off, you must compensate by adding more bits to the encoding. The key point is that to make great prediction, you have to understand the nature of the data. And therefore, to make great compression, you also have to understand the nature of the data. And so Data Edge lets you do that. To give an example, one of the block oracle message payloads is an array of block numbers. If we make no predictions about the values, right? If each value could really take any block number, then Ethereum, would prefer that you represent these as 32 bytes each. To implement the best compression, though, we then say, I know that each number in this array is the next number in a different time series. The numbers next to each other in a given payload aren't related, but each number is related to a number in the previous payload. So we can load that previous state and apply delta of delta compression to reduce that 32 bytes to less than 2 bytes on average, which is a factor of 23 times improvement over sort of the naive representation of those values.
Wow, that is a staggering improvement. And maybe just to unpack that a little bit more, and I know that this is maybe oversimplifying things a little bit, but if we imagine that, the naive method might be to store, a series of block numbers, and each number, let's say the first one is block 1,000,001, and the next number is block 1,000,002, and so on. Just the number of bytes required to store a value as large as 1,000,000 is a lot less than the amount of bytes required to store the value 1, right? And if I'm understanding correctly, that's one of the techniques here, that if you understand that the data that you're compressing is this time series sequence of numbers, then by rather than by posting the number itself, by just posting the difference between the last number and the current number, you can recreate the data, right? You can calculate the block number that was intended, but what you have to store is a fraction of the full number. Is that about right?
Right. We actually go a little bit further than that, right? So your first prediction was a good one. Generally, block numbers are smaller than the range of numbers that's offered by the full, right, 32 bytes of a number in Ethereum, right? A number like 10 million is a lot smaller than whatever 2 to the 32 is, that's 2 to the 256, which is an absurdly high number, more than the number of atoms in the universe, just like silly number. Right, so that's our first prediction. It's probably small, so we can generally, decide, I want to write small numbers with few bits and large numbers with more bits, and that would give us our first level of compression. The second thing that you observed is that each block number that we're going to write is monotonically increasing. So we say, well, just to give some context about the block oracle, we want to say on a foreign chain besides Ethereum what block number corresponds to a given epoch. So we're posting a block number roughly every 24 hours. So that might be 10 million, and then 10 million 1000, and then 10 million 2000. And then maybe it's off a little bit because we don't do perfectly 1,000 per 24 hours. And so then you get, 10 million 3001, right? So your observation was that the deltas there are going to be relatively small, right? So instead of writing 10 million and 1 or 10 million, then 10 million 1000, we can say, well, the difference between those two items was 1,000. And that's a much smaller number than 10 million, right? So we could write, say, 1,000, 1,000, 1001, and 999, right? A sequence like this. And then you look at that sequence, and that's a pretty predictable sequence as well. You just do that sequence, do that delta method one more time, and then you get a sequence like 0, 0, 0, 1, -1. And it's like almost the acceleration of the rate of blocks on the Ethereum chain. A very predictable sequence of very small numbers. Numbers like 0 or 1 or what have you can be represented in a single byte. And sometimes if you go a bit over, like if you use the prefix bar_int encoding, then your maximum positive number is going to be about I think 127. So if you have a acceleration greater than 127, which you do on occasion, then you go up to 2 bytes, right? So this works out to an average of 1.3 bytes for the data that I was looking at in Ethereum over some like small history window.
Wow, that is awesome. Thank you for taking the time to explain the second order derivative. It makes a lot of sense.
Right, but I mean, just remember, like that technique is not going to apply to every problem. You need to look at your problem and make a prediction, and then write your encoding. Right, like I can't write something for you that's going to be applicable to every problem. If you want to squeeze the maximum out of your compression, then you're going to have to really consider the data that you're writing.
Right. Yeah, that makes a lot of sense. And so I guess if the kind of compression algorithm is highly specific to the messages themselves, and I guess not just kind of a local view of the message, but also, the sequence of messages and any relationships that may exist from one message to the next. Yeah, so these are like very, very much application specific methods or message specific methods. So on the one hand, that means we can really eke out the last bit of kind of compression performance and approach those theoretical lower bounds of cost. But I suppose the trade-off is that there's a bit of work that is required to understand your data and design some set of encoders and decoders that can effectively compress and decompress the data. So what do you see the user experience being for subgraph developers who might be writing message decoders inside of the subgraph? And I suppose, on the same track, probably the same developer or at least the same team will also be working on message encoders that might not run in the subgraph, but are solving the same problem effectively. What do you think that this user experience will look like?
So it's going to be a little bit challenging to work out exactly what that should be. But there's really a spectrum, right? Like if you want to, and in fact, a lot of people aren't quite as extreme as I am in trying to get every last bit of gas squeezed off of the L1, right? So there's a gradient of effort that you put into performance that you can achieve. So a very simple thing that we could provide, right, would just be maybe a library that decodes like a normal Ethereum ABI, right? You could not compress your payload data. You would still get a lot of benefit of using the data edge because you moved all of the execution and the storage off of the L1. And the storage especially is expensive on the L1. You move that into the subgraph, and you get benefits right off the bat, right? You don't even think about compression. Or maybe a little bit farther than that, we could give you something that's slightly more effort, but gets you some of the way there, which would be like a general purpose compression method that you could just call, right? And then check and make sure that it works for you and hope for the best. Like one way to do that with Ethereum, I think, is expect most of your bytes to be 0, right? Because like if you look at a 32 byte number, right, and we know that we're not using most of that space, then we can say in our prediction for this general purpose method, make all 0 bytes really small and then non-zero bytes somewhat bigger, right? And we could provide this method for you. You call it, no problem. Or if you want to go a little deeper, maybe we provide methods for very common compression techniques that themselves don't understand the data, but they're like the tools you need to build your own compression system. So like I mentioned, prefix variant encoding. That's just a standard way to encode a number in variable bits. You don't need to write this yourself. We can provide that as a library. To use it properly, you'll have to know the data, but you won't have to get into like the bit twiddly kind of error-prone stuff that I'm familiar with, but most people don't have to touch and don't want to and don't need to, and that's great. So we give you those kind of tools, give you something like a delta of delta gadget, give you a zigzag encoding gadget, and then you can just compose these to make a compression format. And I think that would go a long way, right? And you have all these different options. So I don't think that the user experience has to be terrible. But at the same time, like as with all programming, you get what you put into it.
Yeah, as with life.
Yes.
Yeah, that's interesting, and I kind of see there a spectrum in the sense that kind of highly data type specific compression methods should actually be quite accessible in the sense that we can just provide gadgets or libraries to do that. And maybe the like eking out the last bit of compression performance would really require looking beyond any single message and its data types and more about the relationships of data points in the series to approach methods like delta of delta and so on. Would you agree?
Totally.
Cool. Yeah, that was a really interesting answer. Thanks, Zach. I'm going to take a brief moment to announce our POAP secret claim word, which is for indexer hours, office hours 53. It is verifiable indexing. That is one word and all lowercase. So if you stick that into the POAP mobile app, you will be able to claim today's POAP. Okay.
Alpha leaks.
So Zach, in the GIP abstract, you mention that the protocol will depend on an instantiation of data edge, and this instance will support 2 data namespaces. The first being the cross-chain epoch oracle, and the second being the query version registry. Can you briefly explain each of these use cases?
Yes, although first I want to clarify a little bit. When you say it will support 2 data namespaces, it will actually support all future data namespaces for use in the protocol. Ethereum preamble is just a U32 integer, and the way that they calculate it is by hashing the method signature. So we could add more method signatures to the future, and they will be forward supported by this contract because they all get added to the fallback method and then the subgraph can be upgraded to add an ABI and then decode and have logic for interpreting those methods. So it would be one data edge instance for the entire protocol.
That's really nice. I guess that'll be great for things like message schema upgrades over time.
Exactly. Yep. That's one way that you can use that, is to sort of deprecate old ABIs or old function signatures and just replace them with new ones, and then you can use a new message format. So yeah, that's, and you get what is it, 4 billion of them. So it should be enough, I think.
Should be. Yeah. Thanks for that clarification. So at least when we deploy it, the kind of initial two namespaces, through the selector would be the cross-chain epoch oracle and the query version registry. Could you tell us about each?
Yes. So the cross-chain epoch oracle is its use case is for collecting rewards on chains other than Ethereum mainnet. And this has been a long-awaited feature in the protocol. And the only thing that we really need to solve there, in order so that indexers can submit POIs and then collect rewards, is that we need to know what block on the foreign chain corresponds to the block on an epoch that you're expected to have synced to in order to claim that reward. Simple problem, it's simple to state, but there's been kind of endless debate about the sovereignty of chains and all kinds of interesting concepts and reorg safety. And so this has been like a really long running conversation at Edge and Node and other core teams working on the graph. So we eventually resolved to say, like, for now, just to get the ball rolling, maybe we could use an oracle here while we work out a better design to be used in the future. And so the cross-chain epoch oracle, what it will do is have a set of networks that are supported by the security of the protocol or backed by the protocol security guarantees. And each epoch, it will post a message containing block numbers on the foreign chain that you're expected to use when submitting a POI for that chain. Relatively simple, but what's kind of cool here is that by taking this message plus the subgraph together, which will be a subgraph decoding that message, then when an indexer wants to submit a POI, the first thing that they will do is query the subgraph using a normal GraphQL query. Say, I want to close a POI on this chain. What block number should I use? And it will just return that information from the subgraph, which you can then use to construct your message to close an allocation and get rewards. Any questions about that before I move on to the query version registry?
I was just going to say, I feel like that's such a beautiful example of what we've been talking about. The kind of separation of storage and the reduction of L1 costs to really just be about the most efficient packed data format and super low costs. It's amazing to kind of with cost minimization get that data on Ethereum layer 1 with all of the economic security that it provides, but still retain this beautiful interface that developers have come to expect from the graph. Despite the kind of extreme levels of application specific compression, the developer experience of actually interacting and fetching that data from the oracle is just super easy and seamless. So that's a great example. Thanks.
Sure. Moving on to the query version registry. So to provide context for it, there's a long-winded GIP about how to approach query versioning in the protocol. And the problem that we're trying to solve here is that queries in the graph, in order to be secure, need to be deterministic. And if they're deterministic, that means that you can't add features, because if you add features, that would change the response of existing queries. Right? Like one particularly nasty case is if you make a query for the schema, When you make a query for the schema, that request is backed by the normal security guarantees of the protocol, right? If a indexer tries to form a malicious response to that request, they would get slashed for giving the wrong schema. But if you introduce a new feature, you would then need to expect that feature exists in the new schema that you're returning, right? So how do you resolve this? And the answer is by having the client specify a semver, which will essentially dictate what the expected response is, so that when we're doing cross-checking with the fisherman, that two identical queries against different query version will be allowed to have different responses. It gets into a lot of detail about security implication and where we can do automatic upgrades. And one thing that indexers who are listening here should definitely check up on is the indexer's role in being a method of last resort for providing backward compatibility when GraphNode makes breaking changes, because that may introduce some costs for indexers that I want to be upfront about. So definitely go read on the forum the GIP in its entirety. But one of the problems that you run into is we want for clients to be able to automatically upgrade to the latest version. Because if indexers and GraphNode have to supply backwards compatibility and clients are not upgrading, then they'll have to supply that backwards compatibility across a wide range of query versions, right? Potentially indefinitely, because say a DApp may not update its source code in a year or if ever, right? And that would lead to sort of an undesirable fragmentation of the different versions that are being requested by consumers on the network, right? So we want them to be able to upgrade to the latest version automatically. The problem that you have when doing so is knowing who to trust to do this upgrade for you. So a DApp, say on 1.7.2 of the protocol, may hear from a malicious indexer that if they requested greater than 1.7.2, that 1.7.3 is the new best version. And then maybe that version doesn't actually exist, right? And so they coerce the consumer to upgrade, and then they're able to produce an incorrect response and give that response to the consumer. The consumer can't actually cross-check the response because the honest indexers are not trying to fulfill a request for 1.7.3. That version just doesn't exist, right? And if they tried to, say, backfill it with an old version, then they'd be liable to get slashed if that version was introduced and it behaved differently than they expected, right? So the consumer is just in this awful spot if they trust the indexer to supply the query logic for them, right? So then what's needed to resolve this is a signal of the query versions that are supported by the protocol, and hence the query version registry. Like the cross-chain epoch oracle, all it does is exist to push information, which can then be queried in a subgraph. So either the DApp can query that subgraph directly with a query that is backed by the protocol by on a version that they recognize, or they could say they could delegate that to a trusted entity like the gateway who would index this this data right from the data edge subgraph, and then we could then automatically upgrade to versions that are being supplied by indexers, like whatever the latest or most in supply version that is compatible with the version range that they are specifying. So that's the problem that it solves. Again, like a very natural fit for the data edge contract, and part of the motivation of its design is in these kinds of use cases.
That makes a lot of sense. Thanks for walking us through that, Zach. So we've got 10 minutes left, and I'd like to open up the discussion to everybody who is joining us today. I'm sure there are questions for Zach about data edge and some of the downstream features that we've spoken about. that will depend on it.
Don't want to steal Zach's show, but I do have an update on the indexer cut simplification proposal.
Go for it. I hate questions.
So
I will answer them, but
Ariel has provided some feedback just with regards to capacity. There are some big ticket items being worked on right now, many of which you know about, the L2, the principle-based bonding curve, and some other things. So there is currently, at the core dev side with EdgeNode, not the capacity to prioritize that. Ariel suggested that based on the broad feedback that we have provided, and there was in fact a different forum post, which I can link here as well. I think the key question that was left open was around a important piece, really. The proposed design from Ariel, the initial design, did not allow for negative reward cut settings any longer. Based on the feedback everyone has provided, it sounded like that is something everybody wanted to retain. So I have provided at the end of this forum post a little video that shows the dynamic and the fact that with the new proposal, the dynamic changes once you go into negative territory, because if you keep the settings on the delegation pool, then in the negative territory, it can actually turn into a negative event for an indexer. And that was something that, should not happen. So the way Ariel had initially proposed it is to say, okay, then we just allow no negative cut settings. But the majority seemed to promote that they wanted to keep that in place. And therefore the logic would need to change. So Ariel's proposal right now is that he would love to see for someone from the community to step up and take that on and take that proposal over to the finish line based on the last discussions that we've had. And then it could possibly be merged after review and technical assessment of the proposal once it is designed.
Cool. Thanks for sharing that update, Oliver. We'll be sure to keep an eye on progress on that issue in future IOH. If no one has a question for Zach, I got some. I hope that I'm not the only one, but I will fire away in the meantime. So, Zach, I feel like, we've spoken about some of the applications of data edge in the protocol, and the kind of advantages are quite clear there. I feel like one example that really jumps out at me as something that could really benefit from this kind of architecture is something like Web3 social media. If messages were being stored on chain, and presumably this data edge pattern could be taken to any chain really, but I suppose with the existing implementation, any EVM chain. So some use cases I can just see it being absolutely incredible for. Maybe at least what jumps out at me is the big trade-off is that because there's no computation and there isn't really state in the traditional sense in the data edge contract, I would guess that there's quite a severe impact to composability. But you did hint that might not be the case. Can you share more about that?
Yeah, the composability story is nuanced. Definitely multiple contracts can be given permission, say, to call into data edge, right? And you can think of that almost like a bridge of data into the subgraph. But when you want to bridge data out of the subgraph, that becomes a little bit more tricky. And if you want the subgraph to call a method on the L1, that's just downright impossible. So we don't yet have something written that would bridge data out of a subgraph. But if you think about it, queries are your bridge, right? And you just have something which would accept a query depending on the kind of verifiability for the feature that you're using. So there's a blog post on thegraph.com about the roadmap for verifiability, which I'd encourage people to read. But the basic idea is it breaks down into different stages, where right now we're in this arbitration stage, where verifiability is delegated to arbitrators, right? In the future, we want to move to fraud proofs for indexing, which are similar to other kinds of optimistic methods, like maybe like Arbitrum, when they post a state root that is kind of accepted optimistically, but you might have to wait for a timeout that no one disputes, but someone could dispute that with a fraud proof, lowering the trust requirements to trusting, say, in an arbitrator to 1 of n, where any participant in the network could, say, bring the malicious indexer to court, where the smart contract becomes the judge. And so that's one kind of verifiability. And then another kind would be validity proofs for queries, and that would use zero-knowledge proofs to show that, given a verified database, that the query must be correct, right? So you would implement whatever verifiability logic in the smart contract, which would then allow you to post query results on chain and pull data out of the subgraph back onto the L1 or the L2, and then you could compose things in that way, right? So it almost acts like a separate chain, kind of, where you do have bridges going on and off, and which can introduce latency, but is still composable.
Right. Yeah, that makes sense, and makes me excited. I'm looking forward to future research into bridging query outputs back onto the chain.
Mm-hmm. That's something that we think about.
Yes. Light, bedtime reading. Okay, so we are 2 minutes to the top of the hour. I want to just say a huge thank you to Zach for joining us today and sharing his time and insights with us. Really, it's been a great conversation. Thanks, Zach.
Thank you. And the greatest compliment that I could receive is you go read the GIPs and leave your feedback.
You heard him.
Amen.
I will also plug Zach's talk, Serialization is Everything. I have dropped the link in the stage chat. And if you were intrigued by some of the conversation we had earlier about message-specific compression techniques or how to think about data abstractions, I would highly recommend this talk. It's truly excellent. And so with that, we're out of time. Thank you to everyone who joined us today. It's been an honor to have you here, and we'll see you next week. Bye, everyone.
Bye.
Cheers, guys.
Bye, everyone.
Thank you guys. Bye.